Hey everyone, this is Eddie again. This time I'm going to talk to you about how to add S-curve to your variable frequency drive parameters. So in order to understand what S-curve is, I first want to demonstrate the frequency drive ramping up and ramping down with no S-curve. So this is going to be a linear acceleration from the minimum, which is 0 hertz, to the maximum of 60 hertz across 10 seconds. Then when I hit the stop button, it's going to do a linear deceleration from 60 hertz down to 0. So here is the ramp up. You can see is going up at the exact same rate. And then when I hit off, it's going to go down at a very consistent rate all the way back down to 0. So to set S-curve, I'm going to go into parameter A, and again we can toggle up and down to the different groups. So A is the group that stands for advanced, and we want to go to parameter 439, which is going to be S-curve. And the S-curve is going to take that 10-second ramp up and ramp down time, and it's going to smooth it out. So it's going to accelerate slowly at the beginning and then be linear, and then it will accelerate slowly at the end. So it creates literally an S shape if you graph it out, and it's going to be the reverse when it decelerates. The more I apply, so I can apply anywhere from 0 to 100, the more it is going to smooth it out. And you would use this for applications where, let's say, you want to start a conveyor belt that's carrying a delicate object, and you don't want to start it too hard and cause that object to fall over and break. This creates a very gentle acceleration, but it does extend the total time. Right now I have it set to 10, which is going to be a 10% curve, which means it's going to extend the time by 10% and smooth it out. So my 10-second acceleration is now 11 seconds. So I'm going to accept that. I'm going to go back. I'm going to do this again, and you'll see this time it's not going to be quite linear. It's going to have a slow start and a slow finish. And there you can see it speeds up, and then it's going to slow down again at about 50. And you'll see when I decelerate, it's going to be very slow, and then it'll be linear, it'll go faster, and then it will slow down again right before it stops. So it's slow, 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 and then it speeds up, goes down faster, and then at about 8 or so, you'll see that it's gonna, has a real slow finish. So that is really all you do. I'm gonna just demonstrate this once more. I'm gonna go in and I'm gonna raise it up to be a 30% S-curve, which is gonna smooth it even more. So the first roughly third of it and the last third of it are going to be very slow, and then it'll be smooth or faster in the middle. So it's even more smoothed out. But now it's a 30% curve with a 10-second ramp up and ramp down. So we're looking at a total of 13 seconds now. So it's extending it even more. So you can see slow, 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 and then it speeds up. And then it's going to the acceleration is going to slow again right here at the end. And then we'll see the same thing going down. And it gradually speeds up. And then it slows down more slowly here at the end. So that is it. That's how you add S-curve, and you can add as much smoothing as you need to for your application. Ideally, you want it to be the least amount possible, because the more you add, the more time your ramp up and ramp down will take. So in the real world, if you're experimenting with this, You want to just do trial and error and figure out what is the least amount you can get away with to still meet your needs. And that is it. Thank you for watching.